Today I'm going to introduce to you probably one of the most useful formulas in mathematics. It's called the quadratic formula. The quadratic formula is used to solve for the x-intercepts, or otherwise known as the roots of your quadratic functions. We've learned many ways to solve our quadratics, solving by factoring, solving by taking square roots. Not all quadratics can be solved in those ways. So if you can't factor it, you can't solve it by taking square roots, you can always solve it by using the quadratic formula. The quadratic formula solves every single quadratic function. So these letters here, the A, B, and C that you see in here, these come from the standard form of your quadratic. So you want to always make sure that you put your quadratic in standard form first, and then the number in front of x squared, or whatever the variable is being squared, is going to be your A. The number in front of your linear term, or your x to your first power, that's going to be B. And then C is going to be the constant. So you will always have an A. You won't always have a B. You won't always have a C. If you don't have a linear term or an x to the first power, then when you go to substitute in for B, you're just going to use a 0. The same thing for C. If you have a constant, or if you don't have a constant in your quadratic, then for C, you're just going to substitute a 0. So here are a couple examples. So no matter what the variable is that you have here, you just treat it like it's an x. First thing you want to do is make sure that you put it in standard form. So what that means is you want to get everything on one side, set it equal to 0, make sure that your exponents are in descending order. So I would just have to add this 7v to both sides. So I would end up with 3v squared plus 7v minus 136 equals 0. And then from there, I can see my A, B, and C. So if you want to make a list, sometimes that's helpful. A equals 3, B equals 7, and C equals negative 136. And then all you do is you plug it into your formula. So I'm going to go ahead and rewrite my quadratic formula here. And like I said, we're just going to use x, treat those b's like they're x's. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's one big fraction. So now we're just going to substitute. X equals negative b. So my b was 7, so it's negative 7 plus or minus the square root of 7 squared minus 4 times a is 3, times c, and c is negative 136. And then it's all over 2 times a, and my a is 3. So once you get everything plugged in, you're just going to simplify the right side there using your order of operations. So you want to make sure you do everything underneath the square root first. So x equals negative 7 plus or minus the square root. 7 squared is going to give me 49. Now when you punch this in your calculator here, this number, just punch it in as negative 4 times 3 times negative 136. And that will give you a positive 1,632. So since that's positive, you're going to just make it a plus sign. So plus 1632. All over 2 times 3 will give me 6. All right, continuing to simplify here, x equals negative 7 plus or minus. Now you're going to add your 49 and your 1632, and you get 1681. That's still under the square root, and it's all over 6. Now with a big number like that, cross your fingers, hope it's a perfect square. So punch it in your calculator. Take the square root of 1681, And it turns out that it is a perfect square. The square root of 1681 is 41. So we have x equals -7 plus or minus 41 all over 6. Okay, so this is going to give us our two answers, because remember, when you solve a quadratic, you get two answers. So one of the answers that we have is x equals -7 plus 41 over 6. So we end up with this turns into 34 over 6. And then 34 divided by 6, when you reduce that, is going to give you 17 over 3. So that's one of your x-intercepts. And then it says plus or minus, so we have to do the minus too. So x equals -7 minus 41 over 6, which is going to give me -48 over 6. And -48 over 6 is just -8. Okay, so once you get down to here, if you can go ahead and figure this out, then you need to. So we have our two x-intercepts here. Sometimes you're going to have ugly answers where you're going to have a radical left there. So I'm going to show you now how to simplify those if we have radicals or imaginary numbers. All right, so again, put it in standard form. So I'm going to add the 12b to both sides. B squared plus 12b minus 12 equals 0. And then identify A, B, and C. Okay, so those are coming from our standard form. So if you recall, it was ax squared plus bx plus c. The coefficient of our quadratic term here is just 1, so a is 1, b is 12, and c is -12. And then you just plug that into your quadratic formula. It's always helpful to write the formula down first. X equals -b plus or minus the square root b squared minus 4ac all over 2a. And then we just plug our values in. X equals -b, my b is 12, so this is -12, plus or minus the square root of 12 squared minus 4 times a, which is 1, times c, which is -12. All over 2a, which is 2 times 1. And then you're going to just go ahead and simplify as much as you can. Okay. So we have -12 plus or minus. If you want to, you can just take this whole thing, all the stuff underneath my square root, this is called your radicand. You can take this whole thing, if you punch it in your calculator exactly the way it looks right there, it will give you just that one value there. So I'm going to go ahead and do that. So that'll give me 192 all over 2 times 1, which is just 2. Okay, so now from here, you want to try to see if 192 is a perfect square. Punch that in your calculator. You can just take the square root of 192. It turns out that it's a decimal, so then I know 192 is not a perfect square. So you want to look for perfect squares that divide evenly into it, or you can just make a factor tree and try and divide that. So I'm going to go ahead and make a factor tree. Okay, so 192 is even, so I'm going to go ahead and divide it by 2. 96 is even, so you can divide that by 2 again. 48 is also even, divide it by 2, so 2 and 24. 2 and 12. 2 and 6. And then 2 and 3. So if you're going to go the factor tree method, then you want to just identify pairs of numbers. So we have a pair of 2s, another pair of 2s, another pair of 2s. So that means 2 times 2 times 2 is going to give me 8. So that's 8 square roots of 3 is what that simplifies to. So x equals negative 12 plus or minus 8 square roots of 3 all over 2. All right, and then the very last thing you want to do is reduce if possible. So these two things on top are not like terms, so I can't combine those together. But if you notice, this 12, this 8, and this 2, those are all even numbers. So you can divide those all by 2. So it turns out to be x equals negative 6 plus or minus 8 divided by 2 is 4 square roots of 3. And that's your answer for that one. Okay, and then I have one more example for you. This one is going to give us an imaginary solution. So again, you want to put it in standard form. My advice to you is to always keep that quadratic term positive. Just makes things nicer sometimes. So 11m squared, add 11m, add 7 equals 0. Then I have my A, B, and C are easily identified because this is in standard form. So this is 11, this is 11, and this is 7. So write your quadratic formula. X equals negative b plus or minus the square root b squared minus 4 times a times c all over 2a. Now we're going to just substitute. Negative b, since my b is 11, this is negative 11 plus or minus 11 squared minus 4 times my a is also 11 times c, which is 7. And then it's all over 2 times 11. So now we want to take this radicand, go ahead and just plug that in your calculator. That's going to give me a negative 187 all over 2 times 11, which is 22. Okay, so you have two things to think about here to simplify this final answer. First of all, we have a negative under our square root, so I know this is going to give me an imaginary number. And then 187, you want to see if you can divide that and get a perfect square out of that. Doesn't look like it's divisible by anything. So the only thing you can do here is take out an I. No perfect squares in 187. So this here, that's your final answer. If you were able to break this number down, then you would go ahead and do so. But since you're not able to, this is just how you leave your answer. Okay, so I have a worksheet attached to your assignment today. So there are only going to be 6 problems. So you'll have 2 of each type that I showed to you today. Please try those and email me if you have any questions. Have a great day.